So far we've done the chain rule and the product rule, and this is the third and final one, and it's called the quotient rule. Now, quotient is another word for division, and division we can write as A divided by B. That's dividing B into A. Another way to write division is A over B. So here we've got two functions that are divided by each other. So here we've got f of x over g of x. We've got a particular function in the numerator. We've got another function as the denominator. And so there is a rule for applying or for finding dy dx. So we want to find dy dx. And just like we did with the product rule, we let u be one function and v be the other and find the derivatives of those. So u equals sine of 2x plus 1. Now be very careful once again. We look at that and we know the derivative of sine is cos from our table of derivatives. However, it's not the sine of x. Here we've got another function of x. So applying diff in, diff out, to get u dash, we've got a diff in, so diff in the bracket, and the derivative of 2x plus 1 is 2 times, and when we diff out, the derivative of sine of an angle is cos of an angle, and the angle happens to be 2x plus 1. We don't need that multiplication there, so that's just 2 cos 2x plus 1. So that's u dash, and we've got v equals 4e to the 3x. We want to find v dash, or dv dx. And once again, we've got chain rule. It's not just e to the x, it's e to the 3x. So the derivative of 3x is 3, and that goes out the front, so 3 times 4 e. Now the derivative, so we've done the derivative of diffed in, and the derivative of 3x is 3, which goes at the front. 3 times 4e. Now the derivative of e to something is just e to something, so that'll be just e to the 3x. So we diffed in, diffed out, and 3 times 4 is 12e to the 3x. That's v dash. Now the quotient rule, it's a bit trickier than the product rule. So this is dy dx is equal to, we just write the square of v. V was at the bottom, so this is if y equals u over v. So we've made this our u and this is our v, u over v. V is equal to 4e to the 3x. So we write v squared on the bottom. This is the derivative now. The derivative is just v squared on the bottom. And because we write that first, we just start by writing v. Now it's always times the opposite of u and the derivative of u. This is always minus. If the product rule is always plus between the two, this is always minus. Now because we've got v without finding the derivative and then u the derivative, we switch them now. So this will be v dash over here, and this will be u. So that's the way to remember it. There's always one that has the derivative of either u or v, and the way to remember, you've got to start with this one. You can't switch these two around. So it's always got to be vu dash to start it. And the way to remember that, if you write v squared on the bottom, then just go straight up there and put a v. Don't put v dash. Put v, and then you know it's the derivative of u minus, and then you look at this and you say, oh, this one's going to have the derivative now, and this one I've already got the derivative, so I don't do non-derivative there. Okay, so that's the way. You might find another way to remember all that. So v, once again, you can put your cross through there. V is 4e to the 3x, that's v. U dash is 12e to the 3x, that's v dash. No, sorry, what have we done here? V, 4E, wrong. We go V U dash. So it is 2 cos of 2x plus 1. So I've gone V U dash along that arm, minus. And then we've got V dash, which is this, 12e to the 3x. And then U, sine of 2x plus 1, all over V squared. Now what is V? V is 4e to the 3x. All of that is squared. So a little bit of simplification to go on here. All right, let's take it step by step. We can combine that 2 with that 4. 2 times 4 is 8e to the 3x cos 2x plus 1 minus 12e to the 3x sine 2x plus 1 all over. When we square out this, we've got to square this 4 as well. So that's 16e. Now e to the 3x times e to the 3x, that's what squared means, so that's e to the 6x. Or I could just multiply the 2 times that and get 6x. And this one does simplify. If we take out a common factor, we can't cancel that 8e to the 3x with that because we've got all sorts of other terms up there. We have to take something out the front of the top, and then we can cancel with what's out the top. It has to be connected by a multiply to everything else. So we'll put our 16e to the 6x downstairs. Look for a common factor here. We've got, maybe just use some red here. We've got 2 terms that look similar. And we say, well, what's the biggest number that goes into 8 and 12? And that'll be 4. And e to the 3x is common. So I can put e to the 3x up there. And now we say, what have we got to multiply this by to get all of this term here? So I've got to multiply by 2 cos 2x plus 1 minus, what have I got to multiply 4e to the 3x by to get 12e to the 3x? Well, that'll be just 3 sine 2x plus 1. Put that in brackets as well. Now, because this term out the front is connected to everything else, we don't write a multiplication, but this 4x is connected to everything by multiplication, then we can cancel top and bottom. So we can say, righto, 4 into 4 once, 4 into 16 goes 4. E to the 3x's will go into e to the 6x. You subtract when you're dividing, so that'll be e to the 3x. So we get, what are we left with up the top? Nothing other than this term here. So we get 2 cos 2x minus 1, or 2x plus 1, minus 3 sine 2x plus 1, all over 4e to the 3x. Okay, quite involved, mainly because we've got both of them are functions of functions, but the quotient rule is one that you need to remember. There it is in short form. Identify u is the numerator, v is the denominator, and you need to find the derivative of each. It's always a minus up here. And then if you can simplify, so if you get to that stage there, you're in for a 3 out of 4 mark, and you'll get an extra mark for going down and simplifying it. In this case, it simplifies quite nicely. But you can't just cancel top and bottom. You have to take out a common factor of the numerator, and then you can cancel top and bottom to simplify your answer.